Hello all, this is Ramakant Gupta. I have total 17.5 years experience in IT industry. Currently I am working as a senior engineering manager, a technical architect and a full stack developer. So let's go for the today's topic. Today's topic is about SSL. So let's understand the agenda. In today's agenda, we are going to understand what is SSL, how SSL works, how SSL solves the security problem, and some of the terms which is being used in the SSL TLS. Cipher suite, TLS version, session key, MAC code. Okay, so everyone might have come across this point. What is SSL and how this SSL is going to help me to secure my data whenever I as a client wants to communicate with the server, or as a server whenever I interact with the client, right? So let's understand what is SSL. SSL is nothing but a secure socket layer, and its upper version, the higher version, is called as a TLS, that is transport layer security. This is basically a cryptographic protocol, and it provides a secure communication over the internet. SSL is basically used and solves three problems, that is encryption, authentication and data integrity. So let me give a focus what is encryption and what is authentication and what is a data integrity. Encryption. So let's imagine a scenario. You as a client wants to communicate a server, right? So when you try to communicate the server, you want your data has to be encrypted so that the unintended participant should not be able to read your data or should not be able to interpret your data. So that what SSL help me, it helps me to encrypt my data so that even the man in the middle or a unintended participant tries to get the data, the middleman will not be able to understand the data. Okay, next is authentication. Now when you try to communicate with the server, you should be knowing who is my server. The person whom I am communicating is the intended participant or not. So basically SSL helps me to identify the intended participant. Data integrity. So data integrity in the sense, when you send the data, right, your data should not be broken or it should not be modified. So SSL helps me to understand, to make sure the data integrity has been met. Okay, so let's go one by one and understand. In case you as a client wants to interact with the server, or as a server wants to interact with the client, so how this encryption will happen, right? So basically for encryption there is a two mechanism. One is a symmetric key encryption and another is a asymmetric key encryption. What is mean by symmetric? Symmetric, if you say, is an English word. Symmetric means the same. If the same key is being used for both encryption and decryption, then that mechanism is called a symmetric key encryption. What is asymmetric key encryption? Asymmetric means different, not same. When different key are used for encryption and similar way different key is being used for decryption, then it's called a asymmetric key encryption. Okay, so now let me try to understand. I as a client wants to have a secure communication with the server, right? Or as a client I wants to have the communication with the server. So let's imagine a simple scenario. You as a client wants to interact with the server. So basically let's say you want to interact with Google. Obviously you will not get direct access to the Google private network. So there will be some proxy with whom you will be interacting when you interact with the Google. Maybe let's understand Nginx is one server. Nginx or Apache could be some proxy server with whom you interact. Now a simple scenario, when you send a plain text message, let's say like you try to log in some page, right, and you enter your credential, username, password. If your data is not encrypted, so the data will be sent in the plain text. Okay, so any unintended participant, or in different way we say man in the middle can try to sniff your data or can try to read your data. So the unintended participant over here will be able to view your data, right? So to solve that problem, we can think of encryption. So what is mean by encryption? Encryption means you encrypt your data with some key, and when it reaches to the server then decrypt the data. So for that there is a symmetric and asymmetric key encryption. Okay, so let's see, understand the example for symmetric key encryption. Okay, so let's understand here a client is having one key. Okay, now client will encrypt the data using this key and transmit over to the server. So even though the man in middle can try to get this data, but as this man in the middle does not have the key, so the man in the middle or attacker will not be able to decrypt the data. And once it reaches to the server, if the server is having the same client key, then the server will be able to decrypt the data. But the question is like, for this symmetric key, both client and server should have the same key, right? But here, how you will transmit the data? How you will transmit your secret key, client secret key, to the server? If you transmit over the internet, then again the attacker can get that key and keep with him or her. Now when the client will encrypt the data with that symmetric key, once the man in the middle attack catches that or intercept that data, the man in the middle attacker will be able to decrypt the data. So this does not seem a solution for sharing the key. Now let's come to the asymmetric key. In asymmetric key, how we can share the key for the data encryption? Okay, so let me come to the point. So here, what is asymmetric? In asymmetric, we have a public and a private key. We have a public and private key. Okay, server will have both public key and private key. Okay, so here public key is used for encryption and private key is used for decryption. Okay, so now let's imagine a scenario. Client wants to communicate with the server. So in that case, when the client initiates the communication, the server has to send the public key. It's a public key. As it's a public key, this public key can be with anyone. The client can get the public key. Even the attacker in the middle can also have the public key. Okay. Now when the public key reaches to the client, what client can do? Client will encrypt its data. It's a key. Client will have some secret key. What client will do? It will decrypt its key and share over the network, right? Since if the attacker try to steal this data, as the attacker does not have the private key, so attacker will not be able to intercept that data or interpret that data, right? So once it reaches over to the network, to the proxy server, the proxy server will have its a private key, and using that private key, the proxy server will be able to decrypt the data. Okay, and going forward, decrypt the data, and the proxy server will have the client key. Okay, now going forward, the next communication will happen using the secret key of the client. The client will use the secret key and encrypt the data and communicate with the server, as the server also has the same secret key, client secret key, and the server will be able to decrypt the data. But the problem, let's understand the scenario how man in the middle attack will intercept the data, how it will cause the problem. Okay, so let's understand. Client has initiated the communication. Okay, now this attacker can act as a proxy, and this attacker will also have its a public key and a private key. What this attacker will do, this attacker can give its a public key to the client. The client does not know from where this public key has come. For client, it's understood that I requested from the server and server has shared me the public key. Now the client will use the server's public key and encrypt its secret key and transmit over to the network. Okay, since now again when attacker get this data, since this data is encrypted using the hacker's public key, the hacker will be able to decrypt this data. Okay, so now the next communication whenever client uses its secret key and encrypt the data and passes over to the network, since attacker already has the client secret key, attacker will be able to interpret its data, and attacker is getting all the information, all the credentials of the client. Okay, so again this problem of encryption of decryption does not help me. Man in the middle attack is causing a concern for me for my encryption and decryption. Okay, so there is a next thing, the SSL. So how this SSL help me for this encryption and decryption? So basically SSL helps me to save from the man in the middle. Okay, so let's take an example. Here the server is google.com. Google.com will approach to a certificate authority. In market we have lot of certificate authority. Google Trust Services, DigiCert, these are the certificate authority which is trusted by the organization. This certificate authority basically give the certificate for a particular domain. So now Google approach to this certificate authority and ask them that give me the certificate for my domain, that is a google.com. Okay, what this certificate authority will do, they will ask Google, okay, give me your public key, and what this authority will do, they will generate some signature using its own public key plus the Google public key, create some signature, and then generate one certificate and share this certificate to Google. Okay, now Google has one certificate. Now let's understand how this SSL now is going to help me to save from the man in middle. Okay, now when client initiate a communication with the server, this time what will happen, the server will share its public key, along with the public key it share the certificate also. Okay, now when the certificate reaches to the client will understand the certificate. In the certificate there are a lot of information. In the certificate there is a public key of the server, the CA authority, the certificate authorities, the certificate authority who has signed the certificate, all those information will be mentioned, whether the certificate is expired or not, all those information is mentioned in that certificate. Let me just show you a simple example. Let's understand here. Okay, so if you hit any browser and if you click over here you see connection is secure. So when you click over here, there is a certificate is valid. If you just click over here, you will see all here the certificate which is used by this browser. So here this is the organization, that is a Google Trust Services. So in the sense this certificate is signed by CA, that is a Google Trust Services. Okay, and this is the CN name. In the sense this certificate is generated for this domain app.eraser.io. Okay, and these are the certificate and public key of the server. Here if you see all the detailed information about the certificate. Okay, now what will happen, the client will know via this certificate from where I got the request. I got the request from the intended participant from with whom I am communicating. Now in this case, if the man in middle attacker tries to communicate with the client, obviously the man in middle attacker will not have the same certificate, obviously, right? So in this case, now the client, what the client will do, it uses the certificate and understand that the communication is happening with the intended participant only. Okay, now what client will do, client will then uses this public key of the server, uses the public key of the server and encrypt using this public key its own secret key and share over the network to the server. Okay, since this data is encrypted using the public key of the server, only the private key will be able to interpret or decrypt this data. So with this way, the client data has reached, client secret key has reached to the server. Now server also got the secret key of client. Now going forward, all the communication will happen via that secret key. So this way we are solving, the SSL or TLS certificate is helping me to save from the man in middle attack. Okay, let me go to the next topic, next point. Okay, so this I was talking about what SSL and TLS solve. It helped me for the encryption, in the sense all the data will be encrypted and the unintended participant will not be able to read my data, will not be able to read or intercept my data. Integrity. So when I come in more detail, I will explain you how this integrity will be maintained. So all the data which is passed on from client to server, it is being some MAC code is generated for that data. So whenever it reaches to the participant, they using some key, they generate the key, they generate the MAC code, and if the MAC code is matching with the MAC code which is present in the request, so they understand the data is not been tampered. If it does not match, so it means it's a tampered and that request is rejected. Okay, now coming to authentication. So this server certificate which is sent to the client is able to understand the identity of the server. So this helps me for the authentication also. Okay, so let me take a simple way how this SSL work. There are multiple steps involved with the SSL. Again, it depends on the version of the SSL TLS. So basically nowadays mostly people refer to TLS because TLS is the upper version of SSL. Okay, so TLS has 1.1, 1.2, 1.3. So the TLS is nothing but a protocol. It's a cryptographic protocol for the secure communication. If I say protocol in the sense a set of rule defined to do some activity. Okay, so how it works? So let's go ahead again. Our scenario: a client and server wants to communicate. So when client will initiate the communication, client will say hello message to the server. With this message, client will also share all the TLS version it supports. So it could be TLS 1.1, 1.2 or 1.3. Okay, also client with that message also it sends the cipher suit. So cipher suit is nothing but an encryption algorithm. This cipher suit holds a lot of information. I will give you detailed information what each field, if you see each field, right, it has some meaning in this cipher suit. So here, and also along with that message, it generates a random number. This random number is later used for generating a secret key. Okay, so basically client when tries to initiate a communication with the server, it generate and give three information to the server. That is what is the TLS version it supports, what are the cipher suit it support, and third, a random number which is used for the secret key generation. Okay, once this information reaches to the server will reply back with hello message. And also what server will do, server will choose which TLS protocol it has to use for the communication, and also out of the list of cipher suit shared by the client, which cipher suit the server has selected for the further communication. Okay, also server will also generate a random number. Again, this number is used for the secret key generation. So now the client will receive three information: the TLS protocol version selected by the server, a random number, and the cipher suit selected by the server. Also in the next phase, what server will do, server will share the certificate which is signed by the certificate authority, a trusted certificate authority. Okay, so once the certificate reaches to the client, what client will do, client will validate basically identity of the server. So how it will check the identity of the server? In the certificate it will mention who is the CA of that certificate, who is the CA, basically who has signed that certificate, and next when the certificate is going to be expired, and who, for which domain this certificate has been raised. With all this information, the client understand or identify the identity of the intended server. Okay, next what happened after that, there is a secret key is being exchanged. The secret key is being exchanged. So basically in the cipher suit, if you see, let me just come to, let's see, this is the cipher suit has been selected by the server. This cipher suit holds a lot of information. If you see ECDHE, so this shows what algorithm being used for secret key exchange. What algorithm is being used for the secret key exchange? RSA basically indicates authentication of the digital signature. The next item, RSA indicates the authentication of the digital certificate which is shared by the server. AES 128 underscore GCM, this section indicates which encryption algorithm is used to encrypt the data. SHA 250, this section indicates HMAC for integrity. What is HMAC? HMAC is basically hash map for machine authentication code, message authentication code. I will come in detail what is message authentication code. Okay, so now based on the cipher suit has been selected by the server. If it's a RSA based algorithm being used for the key exchange, so what happens, secret key exchange, so what will happen, the client will use the public key of the server. From where the public key it will get from the certificate. From the certificate it will get the public key of the server, and using this public key encrypt the secret key and send over to the server. Okay, if the key exchange algorithm is selected as a Diffie-Hellman, that is a modern method, then the random number which client has shared to the server and server has shared to the client. Using this random number, a secret key is being generated, and then using the cryptographic algorithm, the secret key is generated using the random number and the cryptography algorithm, and again it is being encrypted using the public key and sent over to the server. Again, like if it is ECDHE, there is a different way this secret key will be generated. Now after this, both the parties will try to generate one session key, and this session some algorithm they use to generate the session key. The algorithm is such a way that both the parties generate the same session key. This is the session key is being used for the further communication of data encryption. Okay, so now till now we understood how this SSL is going to help me, for how this SSL has helped me for the authentication. Now for the encryption. Okay, encryption, now we got the session key. Now whenever the client wants to communicate with the server, this session key is nothing but a symmetric key. How we say symmetric key? Because this session key, same session key is being present at client end, and same session key is present at the server end, and both client and server uses the session key for encryption and decryption of data. Okay, now after this SSL handshake has happened, whenever the client wants to communicate or wants to share the data to the server, client uses this session key and encrypt the data and send over to server. Now as the server has the same session key, server uses this session key to decrypt the data. Okay, the similar way, whenever server wants to communicate, it uses the same session key and reply back. Okay, so if you see this mechanism, it's a multifold. It's multifold in the sense client is sending hello, then server is hello, then certificate is being shared, then there is a key exchange happen, then the session key is generated. So there are a lot of pass and through mechanism is happening. This pass and through multiple communication happens in TLS 1.2, version TLS 1.2. Going forward with version TLS 1.3 protocol, all this pass and through has been resolved to speed up the performance. So all this communication which happened in 3 phases, it has 3 to 4 phases, it has resolved to single phase. In the sense, in the single phase itself, all this client hello, server hello, key exchange session, key generation has been done in single step only, which increases the performance. Okay, now one more thing to remember, this session key is valid only till the session, only till the TCP or only till the TCP keep alive session is live. Okay, once the session keep alive time terminates, or once the communication has ended between client and server, again when the client and server wants to communicate, they have to again then again same client hello, server hello, certificate validation, key exchange, all this process will again happens, right? Again then separate session key will be generated. So this is the way, like it's a secure. Okay, now coming to the data integrity. Okay, so basically what happened, there is a MAC code is generated. So how this MAC code is generated, during the SSL handshake, during the SSL handshake, the client and server agreed on a shared secret key using algorithm like RSA, Diffie-Hellman. Okay, this secret key then used in combination with hashing algorithm and encryption algorithm to generate a MAC code for the data. So what basically happens, the client when send the data to the server, they using the data, they generate some MAC code, and along with the request share this MAC code to the server. Okay, when it reaches to the server, again server based on the algorithm which is selected by client and server and the secret key, it decrypt, it create a MAC code value. It's basically nothing but creating a hash code value, it creates a MAC code value if the same MAC code is being generated, in the sense the data has not been tampered. If separate MAC code is being generated, in the sense some unintended participant has modified the data. Okay, so this way the SSL helps me to solve the third point, or helps me for the data integrity. Okay, so some abbreviation I wanted to give you about SSL. So TLS basically stand for transport layer security. It's a higher version of SSL. SSL is no more being used, but still people are stick with SSL. They prefer naming SSL, but now it's considered to be pronounced as TLS. Okay, MAC is the message authentication code. I told this MAC code helps me for data integrity. Cipher suit is nothing but a set of algorithm that is used for the encryption and decryption of data, for the communication, for the secure communication between client and server. So here I have already shown the example, the one of the cipher suit and all the component of the cipher suit. Okay, so that's it from my side. I hope this video was learning for you. If it was nice and learning for you, please do like, subscribe and share this video. Thank you all for joining the session. Thank you.